Good morning, everyone. It is 10 o'clock, so we are going to go ahead and get started. Thank you for joining us today for our second Water Quality Wednesday of 2024 on this lovely February day. Our topic today is on water management techniques. There should be a poll question that has popped up on your screen. If you could please answer that. So our speakers can better understand who is joining us today. We'll kind of leave that go here for a minute or two longer before we get started. Some housekeeping items. Mark your calendars. We do have our last Water Quality Wednesday webinar that will be on March 27th, and that is over cascading waterways. You can register for that. If you haven't, if you're in this one, you probably had the option, I think, to register for individual ones or the whole series. So if you register for the whole series, you should have that on your calendar as well. There is an upcoming Certified Livestock Manager webinar series on April 4th, and the registration link for that is on the left-hand side at go.osu.edu/CLM. Some upcoming extension events. March 11th through the 14th is the Overholt Drainage School in Columbus, Ohio. For more information, you guys can go to the Go link listed below /ODS24. And March 12th through 13th is the Conservation, Tillage, and Technology Conference in Ada, Ohio. And for more information on that, you can go to ctc.osu.edu. And if at any point you guys have questions, comments, concerns, please feel free to drop those in the chat, and one of us will try to answer those as quickly as possible. So for those of you that may or may not know us, today's webinar is brought to you by the OSU Extension Water Quality Team. The Fulton, Williams, and Lucas counties position is currently vacant. Covering Paulding, Defiance, and Van Wert counties is Rachel Cochran. I cover Auglaize, Mercer, and Allen counties. Putnam County, Hancock, and Hardin County is covered by Paige. Crawford, Wyandotte, Seneca, Sandusky, and Erie is covered by our other team member, Matthew Romanko. And Henry, Wood, and Ottawa County is covered by Amber Emmons. So if you have any questions relating to anything water quality, feel free to reach out to any of us covering your area or any of us in general. And we do have our website listed there at waterqualityextension.osu.edu. So today's webinar, our speakers are Vinayak Shedekar from the Ohio State University and Mark Witt from the Ohio Division of Natural Resources. And Mark, whenever you are ready, I can bring up your presentation.
Okay, yeah, if you want to bring that up, Jocelyn, that'd be great. First off, I'll just give everybody the heads up. I am fighting a cold, so I hope I don't cough or anything like that. But the good part for all of you is you're working on this through your computer, so I shouldn't get you sick. But I apologize in advance if I have an issue there during the presentation. So, they reached out to me here. Jocelyn did, talking about Water Quality Wednesday, referencing wetlands and what ODNR is doing wetland wise to help with water quality. I guess as a heads up, I am private lands biologist. I used to cover all of Northwest Ohio. Now I'm just down to 6 counties, which is much nicer than having 20. They've hired a bunch additional private lands biologists, and I'll show you a map on that at the very end of the presentation. Next slide. So a call for wetlands. As you've probably all heard this at one point or another, Ohio has lost an estimated 90% of its wetlands that existed on the landscape. These were everything from emergent wetlands, coastal areas. They were riverine type wetlands. They were swamp forests. Obviously, the Great Black Swamp was a huge wetland in and of itself. And of course, there's a lot of vernal pools and such that exist in the woods that are left on the landscape. Oftentimes, the only reason they were not cleared for agriculture is because they were the wettest spot on the farm. But in fact, they're usually wetlands. We all know about the harmful algal bloom on Lake Erie, and we're also seeing it on inland lakes and rivers. And it highlights the value of these wetlands to act as natural kidneys. If we had the ability to restore wetlands on the landscape and funnel drainage, whether it be surface or tile drainage through a wetland, we're going a long ways towards improving water quality. Governor DeWine made H2 Ohio Water Quality Initiative to help out with the harmful algal blooms that are being found out on Lake Erie. Obviously, it was a big deal. It was a nationwide issue. So the governor tasked the Department of Natural Resources with trying to find ways to improve things on the landscape to help out with the Lake Erie. Additionally, in this H2 Ohio group, there is a group we refer to as LEARN. Essentially, it is multiple universities who are actually doing water quality monitoring of many different H2 Ohio projects throughout the landscape that have went on the ground. And the purpose of this is to help steer what types of wetlands and wetland vegetation is the most valuable for nutrient uptake. And of course, ODNR Division of Wildlife is actively restoring wetlands with other partner conservation agencies like Soil and Water, U.S. Fish and Wildlife Service, Ducks Unlimited, Pheasants Forever, etc. Next slide. So I'm going to highlight the value of private land management. This is a map of all the public areas in the state of Ohio. And obviously, in the red oval, which is Northwest Ohio, the Maumee River Basin drainage, we have just about the least amount of public land in existence throughout the state. So this highlights the value of working with private landowners to try to improve water quality through habitat projects. Next slide. So you might ask, well, how do these opportunities come about? The Division of Wildlife has a program, we refer to it as the 816 Wetland Restoration Program, where we have somewhere in the neighborhood of $100,000 to $125,000 every year to help out with cost share on wetland restorations. And oftentimes we use this program to restore wetlands in places where they're not eligible for programs like CRP or Lake Erie CREP. There's no annual payment, but it does help to get the habitat on the landscape. Next slide. We also partner with U.S. Fish and Wildlife Service. They have a private lands venue as well as we do. So I work hand in hand with like Jeff Finn, who's the Partners for Fish and Wildlife program biologist up here in my neck of the woods. He's located next door to me. I'm at Magee Marsh Wildlife Area. He's at Ottawa Refuge. So we do a lot of great work. Here's a project in eastern Lucas County where the landowner is actually able to pump water out of a drainage ditch and put it into about a 70-acre wetland on private property. This project was also funded in part by Ducks Unlimited. They've been a fantastic partner. We're right now working on a phase 5 grant cycle. And I think we got a good chance of doing it, but we've had 4 cycles thus far that we have used, basically utilizing Fish and Wildlife Service dollars, 816 wetlands monies from Division of Wildlife, and piggybacking that with DU to get the same product and not run our basically how much money we got in the kitty for projects. So it's been a real nice partnership. Again, it's just simply cost share for restoration. There is no annual payment. Next slide. So in 2021, during COVID, we got tasked with trying to roll out Lake Erie CREP with the Governor DeWine's H2 Ohio water quality incentive bonus. And it's pretty amazing during COVID that we were able to do this many projects throughout the landscape. I think the red dots indicate multiple wetland projects within a mile of each other, but as you can see, we've made a significant impact in the coastal areas along Lake Erie, and Wyandotte Soil and Water has been fantastic, getting a bunch set up down there, and we've also been putting them in Mercer, Auglaize, and Allen County as well. So that's a pretty cool map showing the actual work of H2 Ohio with that Governor DeWine's bonus incentive, what we're able to do. Next slide. So here's an example. This is in eastern Ottawa County out on Marblehead. If you've ever been to a place called Meadowbrook, it's a natural inlet from basically the lake and comes up through there. And with water levels being high, low, we've been having, this guy's been getting a lot of flooding issues. It's been difficult for him to farm. So what we did was we did a restoration via that Lake Erie CREP. To the right sort of shows the engineering design plan that got put together by Ottawa Soil and Water. And next slide. There's the end product. Pretty cool. Established a wetland where it wants to be anyhow. Just a great location. Trying to farm a wet spot, as many of you well know, it doesn't work out too well. From January 2021 to November 2023, we have put 3,800 acres of wetland restoration under contract. And currently we have, about almost 1,900 acres of wetlands that have been put on the ground. The other ones are going to be coming up. The cool part about this program is the cost of the state of Ohio is $2,000 an acre. It's a one-time payment as a bonus they receive. And Lake Erie CREP is the vehicle that helps fund the engineering design and cost share for building it. So it's a really nice partnership. Next slide. So here's a wetland restoration we did along Crane Creek in eastern Lucas County. The creek comes up, spills out onto all this farm ground. We put some rock chutes to be able to allow it to infiltrate the area. Pretty neat. The Lake Erie CREP program, basically it's 90% cost share when you break down all the way the cost share funding goes to establish the wetland. Additionally, the landowner gets a signing incentive, which is 32.5% of the first year's rental payment. It's a 15-year contract. the landowner receives an annual payment every year in October, and basically it pays double the soil rental rate. And they additionally receive a $2,000 per acre one-time bonus incentive. The other positive thing is they retain their CAUV because it's in a federal farm bill program, and additionally, it's taxed at a lower rate than what it is if it's farmed. Next slide. So it's pretty cool complex of Lake Erie crop wetlands that we did in eastern Lucas County. This is near Metzger Marsh in the vicinity of Bono. In the sort of the center of the screen, there's a 50-acre wetland cell that we did. And this landowner, Dick and Linda Carsonston, have been just phenomenal advocates for the program. As you can see in that photo, adjacent landowners have enrolled as well. And we just have, several hundred acres of wetland restoration that has occurred just because landowners see, hey, I can do this type of program and improve water quality. So that's just a really neat spectacle to see that much habitat in one spot in eastern Lucas County. Next slide. Additionally, in Governor DeWine's H2 Ohio initiative, we do have a program. It's called the CP22 program. It's a program where you can roll ground that's along a floodplain, like a creek, a river, stream, where it floods out into a bottom. We've all experienced or know somebody who experiences this, and it's great ground, but you struggle to get a crop off of it. This is a program, basically it's 90% cost share to restore this back to grass vegetation along with trees being planted. And this project here is along the Toussaint Creek in western Ottawa County. The paths mowed where the seedling trees are planted. These areas historically flood in big flood events, and you're allowed to go 150 foot out from the top of the bank. If it's in what's called alluvial soils, you can go up to 300 feet out from the bank. And again, this gets the $2,000 per acre one-time bonus and double the soil rental rate. Next slide. Additionally, there's a Lake Erie Crep field windbreak program. You got an area that has highly erodible soils. You get a lot of wind scouring. It's a program you can sign up for. 90% cost share to establish trees. Division of Forestry will plant these trees for you. They got a really neat turnkey operation. It's a 15-year contract. Again, an annual payment in October. You retain your CAUV value. Next slide. And additionally, you've seen probably a lot of these in some of the counties. Lake Erie Crep filter strip program, 90% cost share established project. ODA is paying a bonus on these. It's a 15-year contract. I believe for warm season grass, it's 175% of the soil rental rate. Next slide. So back to H2 Ohio. A lot of the programs we've been talking about are linked to the federal farm bill. This program here also, H2 Ohio, can do stuff on private, state, federal, county, municipalities to do wetland infrastructure restoration. This project here is physically on Ottawa National Wildlife Refuge. If you look, it says the Crane Creek Estuary towards the upper right portion of the screen. And what I'm showing you is an arrow going both ways. Lake Erie is like a giant bathtub. When you get a hard northeast wind, it raises the level of the lake in Ohio, and vice versa. When you get a hard southwest, it drops the level of the lake in Ohio. So you get water that comes and goes, and as you sort of veer to the left and towards the bottom left corner of the screen, you can see that's Crane Creek. That flows all the way up through Lucas County into Wood County. All this water's coming down through there. And additionally, we have a Vila Road ditch up there that drains a big area. So what we did was where the white squares are, we made reconnections with some fairly sizable units. Pool 3 and MS5, they're each over 225 acres, basically making a connection so the water can pulse in or out of these wetlands, improving the quality of the water for water quality. Next slide. So here's a picture of the structures going in, just to highlight what they look like. It's a big aluminum structure with some screw gates and stop log structures. Next slide. And they're sort of the finished product. It's you can see in the picture on the right, it has a beaver guard on it because the beaver love to plug these structures up, and it's really not fun to unplug them. So you can go up there with a pitchfork and easily slide the debris off of it. In the picture to the right, you can see those hook-shaped things in the middle of the structure. Those are stop logs, so they can set the water level in the marsh, and water can come or go, self-regulate itself. So this is really good for water quality and additionally for wildlife. Next picture. So when I talk about wildlife that benefits, there's been some research done by USGS to show these coastal areas along Lake Erie, there is a huge cohort of nearshore fish communities that use these structures to go into the wetlands and use them as nursery spawning habitat. And there's a picture looking through the beaver guard. And then in the picture to the right, you can see there are some grates that we put in place. And the idea with these grates is they keep the big undesirable carp from going into your wetland and spawning, yet they're sized appropriately so that northern pike, bass, crappie, bluegill, and all the good species of fish can more readily enter the wetland. Next slide. So here's a picture of a project, and they did some sampling for northern pike. Very, very high utilization at this one. This was actually a non-H2 Ohio project. This is Standing Rush that's over on Sandusky Bay, close to 269 and Route 2. But Bowling Green was working on sampling fish there, and they have a high use of this wetland with a very similar structure by northern pike. So just thought it'd be neat to highlight, some of these species that have basically been, not allowed to come into the wetland because we didn't have the infrastructure to accommodate them. We're now able to do this. Next slide. Here's a really large H2 Ohio project that we worked with the Toussaint Shooting Club. They're the second largest duck hunting club in northern Ohio, Winus Point being the first one. But this one's very close to Davis-Besse nuclear power station. And if you look, we basically made reconnections between the Rushaw Creek and the Toussaint River, along with Lake Erie, to allow water interchange where it can pulse in or out of this marsh and flow through the marsh. We initially did a project about 8 years ago where it says U.S. Fish and Wildlife Service reconnection. We put one in there, and with the H2 Ohio funding, we put a reconnection along the Toussaint River. Additionally, the place is called Bob's Bay. There's a reconnection there and the adjacent main marsh reconnection. So this can really be a flow through type of system. And it's 1,000 acres, huge well. So very good for water quality and very good for nearshore fish communities and obviously wildlife. Next slide. There was a lot of infrastructure protection that we had to do on this place. It was in pretty tough shape, but we had to armor good portions of it to protect the work that we were doing there, and it's all part of the cost that was covered by H2 Ohio. Next slide. And here is the Toussaint River reconnection. When we opened that structure, you could have surfed out there. There was perhaps 4 foot of difference between the marsh and the wetland, and it just was really neat to crank that screw gate open and make that reconnection when the project was completed. Next slide. And here's some sampling we did at the Toussaint Club. You know, some nice crappie. Obviously, a lot of bowfin down there in the lower right picture, and hundreds and hundreds of small shiners and minnow type fish. Next slide. Lastly, I'm going to be wrapping this up. We have been working with landowners as well to do, I guess I would call them nutrient quality wetlands. In the slide to the left, basically the tile system on this guy's farm came to a location. He had an outdated shot pump system that dumped it directly into the ditch. We had restored a grand total of 3 wetlands in the vicinity. We worked with that farmer to improve his infrastructure and put new pump, precast structure, and now we can select any one of 3 different wetlands to pump that water into before it exits to the Portage River. This is located near the Ottawa County Fairgrounds, but on the south side of the Portage River. So this is a classic example of nutrient quality wetland, and we've done really about 4 of those thus far, where that was the main focus and habitat was second. So pretty neat to work in cooperation with farmers to do the right thing. Next slide. So lastly, you know, if you have landowners who are interested in contacting us, we have a lot more private lands biologists now throughout the landscape. That's sort of their contact info. You can find this on Ohio Division of Wildlife's website under the private lands tab. And if you have a landowner or a friend or someone you think who might be interested in any of these programs we talked about, I encourage you to have them get in touch with us. And that's all I have.
Awesome. Thank you, Mark, for that wonderful presentation. I know you said you'll be on for the rest of this webinar. So if there are any questions, we will take them at the end. Going off of that, our next speaker is Dr. Vinayak Shedekar. He is an assistant professor of agriculture water management in the Department of Food, Agriculture, and Biological Engineering at The Ohio State University down in Columbus. He also serves as the director of the International Program for Water Management in Agriculture and the Overholt Drainage Education and Research Program. His current research is focused on agricultural water management and involves monitoring and modeling of soil health, hydrology, and water quality from field to watershed scales. His team works at the intersection of soil health and agricultural water management for water quality and agricultural sustainability. His presentation is on drainage water recycling, a win-win for the farm and environment. And I will stop sharing now.
All right. Jocelyn, for some reason, I'm not able to share my screen. I may have not joined as a panelist. I thought I did.
Try it again, Vinayak.
Just want to verify you're able to see the full screen version of my slides.
Yep, looks good.
All right, thank you very much. And thanks, Mark, for that wonderful presentation. It sets a stage for my topic as well. Here, I don't know about others, but it seems like I did definitely get some kind of infection from you, or no, just kidding. I actually, I am also recovering from a bit of a cold and cough type of symptoms. So I'm glad this is a virtual program. If I start coughing, I do have a glass of water here, so hopefully everything will go smooth. So thanks for putting that plug in at the beginning for the drainage school. For those who might have joined late or want to know a little more about drainage school, this is a 4-day training program where we teach drainage design, installation, some of the troubleshooting, and some of the advanced technologies we use for design and installation of these systems. It's about a 4 days of training, hands-on training, a lot of hand calculations and so on. So again, that's starts here during the spring break of OSU on OSU campus. So if you're interested, definitely go to that website and consider signing up. The other event I wanted to also put a plug in for is the 2024 Conservation Drainage Network meeting that's happening here in Columbus during April 3rd to 5th. And it's about a 3-day conference. The first 2 days are conference format. A lot of topics from across the Midwest and some from Canada on conservation drainage. And the third day is a field tour. There is 2 options for field tours. So, all right, well, I'm gonna get started here. We all are aware, I didn't get to see what the makeup was for the audience here, but I'm assuming a majority of you are joining from Ohio or the Midwest, where few of you would need convincing that drainage is a necessity for our crop production. We live in the Midwest, especially where we sit on poorly drained soils, and we get too much rainfall, too much precipitation during the spring months, where removing excess water is a necessity for us to be able to create trafficable conditions and to sustain crops, especially in that initial wet period. Of course, those situations are reoccurring during the growing season, and hence we rely on drainage heavily. And the evidence is here in this map. You can see that Ohio, actually, Northwest Ohio's portions of these counties are one of the most intensively drained areas, not just in the US, but in the world. So, and then typically when you're looking at drainage systems, there is a cost to install them. There is a, so it's the golden rule of drainage is drain only what is necessary for good trafficability and crop growth, and not a single drop more. So that you are essentially getting the function out of that drainage system and not spending too much on it. We'll revisit that rule here shortly, but to put some broader context to the drainage water recycling, if you look at some of the crop insurance payments over last 30 years or so, no matter which state you're looking at, here in the Midwest, here is Ohio, over close to 80% or so of those insurance payments are related to water related damage. Sometimes it's too much water, which is that blue area. So, and sometimes it is not enough water or too little water. So it's either flooding or drought related damages. So you can imagine how important a role water plays and drainage plays in our crop production. The other side of this is how our precipitation and temperature patterns are changing over time and will change over time. So Aaron Wilson is our state climatologist and the state's climate specialist. He has done a really good analysis of going back into the historic data and looking at what that impact might look like, especially for agricultural production. 2 things that are primarily suggested affecting our crop production here in the state Here is a change in temperatures, just the air temperature here in Ohio over since last 1900s up to now, and then what is projected under two different emission scenarios. So in general, we kind of agree that there is increase in temperature that we're seeing, the average temperatures, and it will continue to increase. Here is a percent change in precipitation. The precipitation changes, however, need to be looked at kind of from a seasonal perspective. And if you look on this map, the darker green, any green shades are positive change, and yellow or these orange brown shades are negative change. So what you observe, the first thing you observe here is, especially for Ohio, it's difficult to see here on this map, but at least for Ohio, you're looking at positive change or slight increase in that precipitation in winter and spring. The other characteristic that's not reflected here is it's going to come in buckets. You're going to get more and more larger events or extreme events. But the picture changes in summer. In summer, we're actually going to see less rainfall. And then we're also going to see an increase in the drought periods. So number of days that you don't have any rainfall, you might see that frequency increase as well. So what you're looking at in general is definitely too much water in spring. And then in late summer now, we're going to start seeing somewhat of a drought stress. There is another very simplistic way of looking at this future projections is a study kind of suggests that, well, by the end of this century, you should expect Ohio summers to resemble more like today's Arkansas summers, and winters to resemble more like today's North Carolina winters. So just to put things in perspective, there is going to be a significant increase in the temperature that might cause more evaporation of water, and hence might cause more of the drought conditions. We in Ohio, with our drainage systems, are probably well prepared to handle the wet stress in the spring, even with our existing drainage systems. So the bigger concern here is what is going to happen if we start seeing more and more droughts. So the other broader context I wanted to point out here is all the conversation we're having on water quality. So if you imagine farming today, we are farming not just for profitability, we're also farming for a reduced environmental footprint or ecological footprint. That is becoming our new normal now. So with all the attention on Lake Erie, we know that phosphorus transport plays a major role in the extent of those harmful algal blooms in Lake Erie, and similarly for the Gulf of Mexico hypoxic zone, the nitrogen transport is kind of a key parameter of concern. No matter which water body you're looking at, you are looking at phosphorus and nitrogen together as being the culprits for harmful algal blooms. You need a little bit of both to fuel those. So the main question is how do we farm profitably when we are faced with some of these challenges? How do we sustain? So of course there is practices that are being suggested. There is a long list of practices beyond what you see here on my screen, but conservation drainage. So drainage no longer can be drainage. It needs to be a conservation drainage, and you can implement conservation at different levels. It could be in field, it could be edge of field, or it could be in stream. I'm probably going to focus more on the edge of field component where we're looking at drainage water management and drainage water recycling. Of course, Mark talked about wetlands, and they are a key component of this solution as well. So with that, we're going to start by looking at how the annual water budget looks like for a typical farm field here in Ohio. So on average, if you look at the state, we're looking at about 40 inches of rainfall. But of course, there is some spatial variability. As you start from the northwest corner of the state, you're looking at slightly less rainfall than the annual report average reported for Ohio. So somewhere between 32 and 36 inches. As you go further south and east, you're looking at reaching that 40-inch threshold, or sometimes exceeding, depending upon which time period you're looking at. So this is a average between 1930 and 1980s. This is the average between the 1950 through 2020. But in general, I think 40 inches is a good number to use. Just know that here in these counties, you're actually getting a little bit less than 40. All right, so what we did was Dr. Kevin King and his group with the USDA ARS Soil Drainage Research Unit, they have a extensive edge of field monitoring network here in Northwest Ohio. All those little dots are their monitoring points. Some are, there may be a point that I monitor here, but about 200 site years of data is what we had available. And when you put together all of the 200 site years of data from these farm fields and look at how the water budget looks like, we came up with about 40 inches of annual precipitation on average. Out of that 40 inches, about 22 inches plus or minus 5 inches goes back right into the atmosphere as evapotranspiration. So the crops are transpiring, taking the water out of soil, and there is also evaporation happening throughout the year. So these are annual numbers. So out of the 40, 22 inches goes right back into the atmosphere. About 18 or 20 inches that is left in the soil. About 11 plus or minus 4, so 11 to 15 or 10 to 15 inches of water actually finds its way out of the tile outlet. So almost half of the water that stayed on that landscape has found its way out of the tiles. And then the rest of it either finds its way through surface runoff, or we had an unknown component which kind of includes the deep seepage pathways or lateral seepage pathways reaching out to the groundwater. So keep these numbers in your mind when we're talking about drainage water recycling, because these numbers become important. So we're looking at an annual basis. Let's look at it on the monthly basis. So if you start in the month of January, go up to December, this is about a 30-year average rainfall that you see. The blue line here is 30-year average monthly rainfall that we receive. The green shading line that you see is crop evapotranspiration or crop water demand. How much water the crops are needing. So of course, in January, there is no crops growing. If there is anything growing, such as cover crops or wheat, the water use is very minimal, almost none during those months. And these are the months when you have excess water because of that precipitation or snow melt that you get, that you have to get rid of. But the picture kind of changes when you get into the months of June, July, and August. We're still getting about 4 inches of rain in any given month, but the crop water demand significantly goes up during those months. So what you're looking at is naturally in Ohio, when we're going, especially grain crops, corn and soybean, our crops grow with a natural deficit. So whatever crop yields you're seeing in your rain-fed systems, they are despite of that deficit. It would be interesting to quantify what that deficit looks like, because that's the missed opportunity. If you could provide that difference between how much you got in rainfall and how much the crop actually wants to transpire, you could be looking at potential yield gain. So just to put things in perspective, I gave you a 30-year average, but in any given year, these graphs can look crazy. This is 2023. And this really is a good example where we had probably not that bad a precipitation pattern in the winter months, but right after planting, the faucet kind of turned off, and we almost did not have enough rainfall. So that shading that you see is the 30-year average. So we had below average rainfall in those 2 months, causing another spell of deficit. But then we had some counties like Wood County here, where we recovered that deficit because there was a little more rain in July and August. So if you look at the distribution across Ohio this year, this last year, it's really interesting. Some counties are looking at their bumper yields for corn and soybeans, and some counties have looked at their worst yields because of the drought stress. So when you put all this together, our estimate is that our crops are, our grain crops especially, are short by about 5 to 5.5 inches in a season, in any given year, in an average year. And then this deficit is not consistent between June and September. In July, August, and September, that it reaches a peak, and that peak demand is about 1/4 inch per day. So if there was enough water, the corn especially has the potential to pump out about 1/4 inch of water from that soil profile in one day. So that kind of becomes our reference point here, is a number of like 5 inches of deficit. Now, I just mentioned earlier that we're looking at a warmer future, which means there is going to be a little more evaporation, and maybe this demand would change. This is the current deficit. Maybe that deficit would be greater in future. And if there was greater deficit, what is the potential for the crops to stay at the crop yield levels that you're seeing now? Or are those crop yield, is that crop yield potential going to drop just because the deficit now is going to increase? So a colleague of mine, Dr. Rajveer Dillon, he is at Central State, and he kind of put that question, asked that question to machine learning models. So what he did was he took county level data, weather data from all over Ohio, county level crop yield data, fed all the data from last 30 years to these machine learning models. So the models kind of learn to predict crop yield in response to a change in rainfall or temperature. And here is a map that shows what the model has predicted if in today's weather you are producing corn or soybean, right? And then he said, well, let's, can you predict what happens in a future climate scenario where there is low emission? That means lower, slightly lower increase in temperature and similar change in precipitation. And what would happen in the worst case scenario? Anything that you see in yellow or orange is a decrease in crop yield. So if you continue to have rain-fed corn in future, and if any of these models happen to be anywhere being close to accurate, then you're looking at not increase but a decrease in crop yields, which kind of indicates that you probably need to think about supplementing with a little more water to these crops so that they can sustain their yields. So I have not verified this yet, but I am, as of now, guessing that the actual deficit that we're going to face is probably not going to change more than an inch in future. So I added an inch here and about 5.5 to 6 points. So maybe 6 inches would be a good number to use for Ohio as a deficit, seasonal deficit. I also don't see this peak demand changing as much. And that rate is going to stay the same. So too much water, too little water, both of these coexist here in Ohio, and they are going to affect every aspect of our operation in different ways. Trafficability, crop growth due to wet, stress, compaction, kind of leading towards lower crop yields. That's kind of the conclusion here. And there are ways that we can handle this. My first thought was, well, drainage hasn't changed since 1900s, but the climate has, or the weather patterns have, and we are still able to manage our cropping systems. We're still able to get the yields that we need. So does drainage really need to change, or can it just stay the same and keep performing the way it is performing already here in Ohio? So can we still continue to use this golden rule of drainage? And unfortunately, my conclusion is that we can no longer use this golden rule of drainage. So we have to modify it. We do want to drain only what is necessary for good trafficability and crop growth, but there would be situations where you would want to drain more, such as in future spring weather, but you may need to store and recycle that water for the summertime. So it's going to become more of a necessity, even if we're not feeling it right now. And the first step towards building that resiliency is, let's just do the minimum and see if we can survive. So the one good practice that comes to my mind is the drainage water management or controlled drainage. For those who don't know what that means, is if you have a free draining outlet, you essentially put a control structure at that outlet and stack up boards in that control structure so that you can raise the water table instead of letting the outlet freely flow. Now, the controlled drainage has been studied here in Ohio for last 20 plus years. Dr. Norm Fauci, Larry Brown, and Dr. Barry Allred, they have done outstanding research on this practice. And we know that this practice works in flat landscapes for reducing discharge. It has really outstanding water quality benefits, reduces up to 40% nitrate reduction. And it does have some benefit to crop yield, especially in dry years. We have seen about 6% yield benefit to corn, about 3.5% to soybeans within that zone of influence. ODA has conducted similar surveys and found out that over 50% of the producers actually experience an increase in corn and soybean when they're using controlled drainage during growing season. Now, we know that controlled drainage is a win-win practice, mainly because it has the potential for crop yield increase as well as the benefit to the water quality. However, it does not give you the surety that it will supplement all the water that is needed. My estimate tells me that there is about an inch of water that you can gain in a soil profile by practicing controlled drainage during the growing season. It's a passive practice. You're going to retain more water in the field, but that doesn't mean you're going to retain water throughout the growing season. That water is going to probably get used by mid-July or end of July. And after that, you're going to still end up with a situation where the crops are still suffering from a deficit. And that's where I think Supplementing additional water is where drainage water recycling or recycling of drainage water comes in. And it's, as the name itself describes, it's a simple practice where essentially instead of letting your drainage water discharge into a ditch, you're creating a storage structure of some kind, a reservoir, and using that water to then irrigate the cropland, whether it's that same field or some other field downstream. But essentially storing, capturing, and then using that water for irrigation is the concept. And we have seen some really good benefits with respect to the water quality, because you're essentially reducing the discharge from that field going into the downstream water bodies. And it also seems like we can apply it to landscapes that are not flat. So with controlled drainage, as I said, the first criteria was it had to be a relatively flat field. You could potentially look at rolling topography where you could still be capturing the water and then pumping that back uphill for irrigation. When it comes to capturing the water, I think I covered that with a reservoir. And then when you're irrigating, you have multiple options to go for irrigation. Could be an overhead irrigation system or a subsurface irrigation system or a sub-irrigation system. This also has recently been added to a NRCS practice standard 447. Which is now called irrigation and drainage tailwater recovery. It used to be irrigation tailwater recovery. Now it is irrigation and drainage tailwater recovery. So there is opportunity for some equip dollars to flow through for this practice. Unfortunately, right now here in Ohio, it's not on our equip list. So even if you wanted to, you won't be able to get NRCS funding for establishing a drainage water recycling system. There's multiple benefits, as I mentioned. Irrigation is definitely going to help you increase the crop yields, water quality benefit. There is some potential to actually have an impact on downstream flooding, especially if you're putting a reservoir at a larger watershed scale. And then there is possible options where you could be integrating this with your manure application, using it for dilution and so on. There are co-benefits as well. There is co-benefits with respect to the wildlife habitat and recreation as well. Here is a regional synthesis that was done on drainage water recycling. We had drainage water recycling. We had an increase in, I apologize, I'm working from home and there's some background. So there is definitely some increase in crop yield response with drainage water recycling. One step further beyond that, we do have the option of pairing it up with more ecological practice like the wetlands. And interestingly, this research was done in 1990s. So we have already proven here in Ohio how a drainage water recycling system can exist with, can you please? A drainage water recycling system can exist with a wetland system. Rachel, I'm gonna take a quick 1 minute pause here, if you don't mind. And I will finish my talk. If you want to entertain a couple of questions here, I would appreciate that.
Yep, that sounds good, Vinayak. It doesn't look like there's currently any questions in the Q&A here, but if anybody has any questions or comments on what Vinayak has shared so far, please go ahead and put those in the Q&A. There's also a feature where if there's a question already in the Q&A, you can actually upvote it if you're also interested in that question. So we'll just take a quick pause and we'll let Dr. Shedekar handle his stuff, and then we'll be right back.
I apologize for that. I am back. And I missed if you said anything, Rachel.
Nope, you're good to go. We don't have any questions right now.
All right. So coming back to the wetland reservoir sub-irrigation systems, essentially what we're talking about is the water from your field is, instead of going directly into the reservoir, you're routing that to a wetland cell so that the water gets some level of treatment, especially for the sediment part of it, because when it comes to irrigation systems, they are very sensitive to having sediment in the water. So the wetlands definitely provide that added benefit there. And there was 10 or 15 years of research done. Here is an example from Defiance County, where they had a field that was sending water through a wetland into a reservoir, and that was being pumped back into those fields. There's a nice fact sheet on the Transforming Drainage website that shows you the benefit of a versus system. And instead of calling a win-win, it's actually a win-win-win system where you're a practice where you're getting the crop yield benefit, the nitrate, or the water quality benefit, as well as a habitat benefit. So I'm gonna quickly talk about the capture and storage component of this system. And if you were to apply 5 inches on 40 acres, an acre inch is roughly about 2,500 gallons, slightly more than that. For simplicity, I'm using 2,500 gallons. So 1 inch of water over 40 acres is about 1 million gallons, and 5 inches of water over 40 acres would be about 5 million gallons. So that's how much water you would need if you were to apply 5 inches over one season, right? So that's the kind of capacity that you would want to build in your irrigation pond if you were to irrigate 40 acres. So here is a site that we're developing right now at OSU Lima campus. And we're collecting surface water and drainage water from about 40 acres of these two fields. That's coming into the pond, and then we're going to demonstrate overhead irrigation on one side and then sub-irrigation on the other side. So that's kind of the intention for this site. Then let's see. Another aerial view after the site. This is also during the construction of the site, while the pond was being built. As you can see, it's a pretty significant footprint. This is about a 2.6 acre water area that is gonna happen, about maybe close to 3 acres of area that went out of production. In this case, during construction, the design process and the construction process is very involved and requires you to have a professional engineer, and a pretty big team to kind of manage that project. One hiccup we had was we suspected that there were some sand veins at the bottom of the pond after it was dug. Luckily, it ended up being a controllable situation, but those kinds of situations can create a bit of a limitation here, or at least a need to take additional measures. One unique thing we have done is we have fitted our pond with a automated control system, or a smart drainage system, which would allow us to remotely operate the outlet of that pond so that we can control the water level in the pond, even from our office here. and this is how it looks like probably 2 weeks ago, about half full as of now. When it comes to drainage water recycling, these are some of the questions as a farmer you should be asking. Number one is, can I afford it? The project itself costs a huge amount of money upfront. Yeah, but when you look at the cost economics, you do have a return on investment that you can calculate based on that benefit that you see. How much land will be taken out of production? What is the opportunity cost there? What are the trade-offs between for the cost and the payback periods? And then who will pay for it? Can I get any cost share or assistance on this? And the answer is depends as of now, mainly because the practice standard 447 is not yet approved. I shouldn't say approved, but adopted here in Ohio. When you're kind of investing into a completely new system, especially irrigation, is not every farmer is used to. There is a bit of a learning curve, and the maintenance and the troubleshooting needs, all of that probably comes up as part of this. In terms of planning process, just to give you some idea on how large a pond we're talking about, as I said, for 40 acres, the calculation for us was about 2.5 acres, 8 feet of depth and 2.5 acres of pond area to irrigate 40 acres. So if you look at that ratio between the pond area to irrigated area, essentially what you're looking at is about 1 acre of pond area per 15 acres of irrigated area, or somewhere between 1 to 15 and 1 to 13 or 1 to 10. So it's a significant amount of storage area that you need. So what you probably need to be thinking about is, how can I shrink this? Do I really need to store all 5 inches ahead of time? Or do I build a pond only for 3 inches, but have the ability to supplement that? Because if you're reducing the amount of storage needed, that means you're reducing the footprint of that pond. And here is an example. Here's some alternatives you could use a deeper or multiple ponds, refill the pond using groundwater or nearby stream or ditch. If allowed by the law, I have to add that caution there, or any other sources of water that you can find. If you're using a more efficient irrigation system, then maybe you don't require too much water to apply. And then maybe don't just aim for all 5 inches, just aim for do more of a supplemental irrigation only during critical periods. So here is just kind of a visual scenario where this is the actual size of the reservoir that's required. And here is different scenarios that you could come up with that could make it shrink the size of the reservoir, or put the reservoir in a spot where you could be looking at a kind of a corner spot where it's not a production area. When it comes to irrigation, as I mentioned, you have the option of overhead irrigation and sub-irrigation. Center pivot systems are very well known. This is a newer system, 360 rain system that has recently come on the market and seems to have a lot more potential because of the portable nature. So it's not bound to one field. You could transport it from one field to another, and it spools the supply line on its own, and so on. So it's a pretty cool system, has a lot of potential. Overhead irrigation has been tested here in Ohio. A lot of anecdotal evidence. Farmers in Southern Ohio are already using it, and they're seeing about 65 to 100 bushel yield benefit. And for corn, the return on investment is really good on this system, especially in Southern Ohio. So irrigation itself as a practice has been very well proven. And for irrigation systems, there is some NRCS funding mechanisms that are available. The criteria is, however, you have to be irrigating already to then sign up for some of the other management type of funding mechanisms. The other option is sub-irrigation, where essentially you're using the drainage system for irrigation. And what you're doing is you're pumping the water out of the pond into your drainage system. And then that's going back. So you're collecting the water from the drainage system into the pond. And then here is the loop going back. You're pumping that out. You're not necessarily putting it through the same outlet pipe, but it would be ideal to pump it into the most upstream portion of the field first and irrigate those portions, and then come downhill as you are irrigating those different sections. And you can make this happen with the help of these control structures that I had mentioned for controlled drainage. Essentially what that does is it is pushing that water back into the system along the laterals. So if these are the two laterals that you see, the water that has been pumped back into the system is going to be pushed out of those laterals, and it's going to push the water table up. The key is to bring the water table in the root zone uniformly above those tile lines, and especially within the root zone. So you need to be pumping water continuously until you have maintained the water table in between the two lateral lines, not just above the laterals. Again, sub-irrigation research has been done over the last 25 years here in Ohio, and it has been proven that for corn, we're looking at about an average yield increase of up to 20%, and in dry years, it goes up to 30%. For soybeans, we're looking at 10% yield increase, 12% yield increase, and in dry years, it looks more like 25%. So these, again, there are really good references here in terms of these fact sheets. I'd be happy to provide those links at the end of the presentation here. But here is why I'm talking about drainage water recycling as a practice rather than irrigation as a practice. If you look at the map of Ohio, we don't have good surface water sources here in Ohio, in Northwest Ohio. We don't have good subsurface water resources. This is the groundwater map of Ohio. And any colors that you see, blue or darker, whatever this color is, are the ones that could potentially support a center pivot system or irrigation system. Anything this color, or this color is essentially a well discharge that is not going to be able to support an irrigation system. So in July and August, when you're actually needing the water for your crops, there is absolutely no source that you can tap into for irrigation. And that is the primary reason why we need to think about storing the drainage water that you are otherwise letting go during the non-growing season. So if you look at your after harvest, the drain flow picks up. This is drainage outflow on monthly basis. By the time you're ready for planting, you have already let go about 8 to 12 inches of water out of your tile systems. That water, we don't need all of it. We need about half of it that you can store. During growing season, you're looking at anywhere between 2 to 4 inches, but there is a very high variability and uncertainty in the growing season. So the best way would be to bank on that water that you're otherwise letting go during the non-growing season, store that, and then use that during the growing season. Let's see. This is probably my last or second to last slide. Where do I start? I would start looking at the maps for my entire farm, and especially if you have drainage maps for individual fields, see if there are locations, and Mark would probably relate to this and probably argue with me that, hey, you're talking about finding good spots for wetlands, and I totally agree with you. I think there is space for wetlands and these irrigation ponds to coexist. If it's, of course, there is an additional criteria for wetland design. However, if a location was suitable for storing large amount of water, that is the main criteria that you want to use. Of course, there are additional things that you want to look at. The best resource on drainage water recycling, I would suggest, is not my website, but the Transforming Drainage website. And if you go to that website, you will find outstanding resources on drainage water recycling. The technical help can come from your local soil water district, OSU Extension Office, or NRCS staff. I'm always happy to help people. I get a lot of calls about who are just thinking about the system and want to get started on that route. If you go to this transformingdrainage.org website, you'll find this fact sheet and you'll find it very useful. It's a questions and answers type of a format, and they have some case studies, and there is a case study from Ohio there. So very useful information on that website overall. If it comes up, I'll be happy to share my screen again and show you the website and some of the tools and videos that they have. I'll stop there and take any questions there may be.
Perfect. So it looks like, Vinayak, I guess we will start with you. There are a couple questions for you. The first one that I have seen is, with projected water shortage for crop production, do cover crops and practices that increase soil organic matter become more important?
Absolutely. I think they are a very important part of the equation. However, they are not the complete solution. So just like I said, controlled drainage, if you have a controlled drainage on that side, I would give maybe 1 inch of credit. If your soil has maybe 1% extra of organic matter, and you're practicing cover crops, I would probably give it another 1/2 inch credit on top of that in terms of soil moisture conservation. It is said in the soil health community that 1% of organic matter can soak up 1 inch of rain. It is true. The main issue we're dealing with here is we're talking about the months of July, August, when you may or may not have that rain to soak up. And then the demand, as I said, is about 1/4 inch per day. So even if you had 1 extra inch, that's going to last you 4 days, not all 2 or 3 months. So that's kind of the challenging part. But yeah, it is definitely an important piece of the puzzle.
Perfect. And looks like the second question for you is the economics of this practice and the payback time involved in that. 1 inch of water is worth about 5 to 6 bushels of corn or so, they have heard.
Yeah.
What?
I think that there was a slide that talked about how just irrigating, you have the crop yield benefits. I guess I didn't include the bushels on there, but I would tend to agree with you if you were looking at about 6 bushels per inch. It's kind of a general statement that you're referring to. Unfortunately, I do not have long-term data from Northwest Ohio from overhead irrigation. But as I said, with sub irrigation, we have found 20% yield boost with corn with that full irrigation potential that you would achieve. And that's equivalent to about 40 plus or minus bushels, which kind of matches up with your estimate here, Van. So.
And then the next one is, what percentage of fields that are tiled with drainage water management are suitable to be converted to sub-irrigation?
Oh, that's a really good question. That's part of the reason we had really good research and good response from sub-irrigation, but not so good adoption of sub-irrigation here in Ohio, is because of the limitations in terms of site suitability. So for sub-irrigation, you need a site that is allowing more of lateral movement of water than vertical downward movement of water. Imagine you're trying to put water through 4-inch pipes that are 40 feet apart, and the water has to travel at least 20 feet from either of those laterals to reach the middle, and then it has to rise up by another foot or so. So you're looking at a pumping requirement that is very huge, and that's where the challenge is. If the soil, the subsurface below the tile lines, if you do not have impervious surface or slightly highly permeable layers, then you're gonna likely lose a lot of water. If you have sand veins, that's another issue. Even the shallower depths of soil, if they do not allow for good movement of water, then that's a problem. Wide spacing is a problem. So there were many reasons why sub-irrigation could not be feasible. One thing, I actually had a slide here that said, well, if you're doing 20-foot spacing, 15-foot spacing, which is happening now here in Ohio, I haven't recommended that to be the drain spacing if you're only asking for drainage. But if someone is putting in very close laterals, if you put them a little bit shallower and then they are closer together, they are good candidates for sub-irrigation. So that's probably the reason why we haven't seen so much gain in sub-irrigation. So going back to that question, what % of the landscape is suitable for sub-irrigation? If you go to that Transforming Drainage website, there is a map tool that you can see that shows sub-irrigation suitability for entire Midwest, and you can zoom in and see what the suitability is for your own location. However, I wouldn't rely on that map only to make that determination. Technically, any soil should be that has controlled drainage is probably a good candidate for sub-irrigation, but you need to do additional investigation for the suitability of sub-irrigation as well. So.
Perfect. Thank you for that answer. And then it looks like there's one more for you. This last one that I'm seeing here is, what is the expense of drainage water recycling as compared to 100% groundwater irrigation, assuming that groundwater is available?
That's a really good question. Unfortunately, I don't have both of those figures. The site that we're building at OSU Lima, it has, the pond itself has cost us about $200,000, give or take. And the irrigation system is going to be another $100,000. However, in the irrigation world, if you ask, for example, MSU has some fact sheet. Michigan State University has a really good irrigation website and resources. And when they report the cost between groundwater well-based irrigation system versus a reservoir-based irrigation system, for some reason, their costs look exactly the same. So their cost estimates are about similar to what it costs you to install drainage, $1,500 per acre type of an estimate if you're going for a 100-acre type of a system. However, as of now, I don't really have those numbers of my own to quote.
Perfect. I don't see any more questions for you, Vinayak. Mark, there are a couple questions for you. This first one is, what is the current lead time to get a wetland involved? It sounds like there are a lot of cost share programs available. If so, does that mean a long wait? Will the programs be available for a set amount of time?
Okay, so, excuse me, to answer that question, it sort of depends on the program you're gonna go in. The H2 Ohio program is gonna be in place as long as, Governor DeWine's in, office. And like I said, that's piggybacked on Lake Erie CREP. So usually from start to finish, you're usually looking at about a year to get enrolled in Lake Erie CREP. The other programs can potentially be a little faster than that. It just depends on the scope of your project and what we're trying to do.
Awesome. And then, do you guys have any wetland implementation goals to kind of go off of the Lake Erie goals, other than those wetlands that are already in contract, that are already, made or being implemented? Any certain number?
There is a cap on Lake Erie CREP, and off the top of my head, I can't tell you what the acreage is for that, but we still have a good ways to go with acreage on that. So, if somebody's interested, they just need to make an appointment to have us come out and visit with them.
Perfect. I am not seeing any other questions. Real quick, before we get to the CCA credits, we did just want to kind of pop this in here. Matt had made this lovely story map of wetland restoration, kind of the progress of how it gets started, before and after pictures. It's a very interactive media source, and Rachel has just dropped that link into the chat. Thank you for that. You can see it at this link, and it goes over kind of the basics of what the area looked like before, during implementation, how those are decided with HUCs, and that sort of stuff as well. So if you get a chance and you're interested in looking at that, I would highly encourage you to do so. It is a wonderful resource. And then here are the CCA credits. So if you would like to scan the QR code to receive that credit, the app will automatically sign you in. If there are any questions with that, please reach out to me at bert.32@osu.edu. And then if you need CLM credits, there is a poll for that as well that is being launched right now. So I will leave the credits page up here for just a little bit while longer. Thank you to everyone for joining us today. We will have another Water Quality Wednesday on March 27th. We hope you can join us at over Cascading Waterways. And any questions, I will put the email up here in just a second. Please feel free to reach out to us. I know there have been some questions on the recordings of this, and those will be posted and available at the OSU Agronomy Team YouTube page for later viewing. I am gonna go. And all of that is listed right here. So if you guys could please take a moment to respond to the survey that will launch when you exit the webinar, it would be much appreciated. And thank you to our wonderful speakers for being here with us this morning and offering all of your guys' knowledge and expertise. And if anyone has any questions, please feel free to reach out to us or to them individually.
Thank you for the opportunity. Have a nice day, everyone.